First found Haskell in a functional programming course, banged my head a lot, but I knew there was something there. Did the second course and then procrastinated my master's by going through Haskell programming from first principles and failed my master's, but it's a good ending in the end. But first, I worked in Logograph, writing a lot of Python, being disappointed in dynamic systems, but I snuck some Haskell in, so that was fun. Apart from the servant, I won't talk about that. And now I work at Formation, so it's a happy ending that I learned Haskell and ended up in a Haskell job, and life is so much better now. And my learning journey just keeps continuing. And that's why I'm at LambdaConf, of course, and that's why we're all here. So, I would argue we're much more functional when there's good documentation on our libraries that we're using, or even writing. Because that's the first point of contact. It's you know this library does something, but you don't know the internal. So you have to go through it. Basically click into the links and check out what the hell it does and how it organizes the library itself. Otherwise, we'd have to just grok through the source code. And my friend Doug Beardsley actually made a good point last night. As soon as you start looking at source code, you've lost abstraction. Because if you're scared that you don't have any guarantees, then what's the point? And past Fintan can sometimes be smarter than future Fintan. So I'd like to go back and see that there was comments on complex pieces of code and be like, oh yeah, that's what I was thinking at the time. And also, I would say open source documentation on open source code is super helpful for people coming in. And then also encourage people to write more documentation on your open source code. I don't know how adept are people in Haskell? How often does anyone use it? Show of hands. Using Haskell. Cool. All right, cool. I might be able to skip this. Basically, I was just how do you search things in Haskell? So searching packages, searching modules, function names, type signatures, and there's 3 things that come to mind. I'll just go through them. So haskell.org/Google, which was the first Haskell API search engine, I believe. It goes through Hackage to find things and has a command line tool. So you're able to search a package name, search the module. You can type in a type, so A to A, and it retrieves back ID and a bunch of other things that slightly match that. I prefer using hoogle.haskell.org because it usually finds things that I'm actually looking for, whereas the other Hoogle doesn't. It's also got a reactive interface, so as you're typing in the search bar, it'll search things as you type, which is awesome. And then there's, oh no, janked the HDMI cable. Anyways, there's Stackage, which you can search the snapshots, so the LTS resolvers and whatnot, which I find really useful because we use Stack at work, and then you can find which versions of libraries appeared in different snapshots. So, onto the meat of things. Yes?
I would just say there's one other tool that
Oh. Hayu?
Sorry?
Hayu?
No, it's it's an integration to Hackage, but it's a Mac client called Dash.
Oh yeah, cool.
It's I had to move to Linux machine, and it's keyboard shortcuts and Dash are used for that.
Nice.
Not to stay on Linux.
Yeah, cool. Did you pay for that?
It is $25.
Okay, yeah.
Yeah, it's so amazing.
Sweet. So when we're writing code, because code is the fun part, we sometimes let documentation slip. So I'm going to propose a way to think about documentation as you go along. And I do this by breaking it up into categories. You know, like functional programmers love categories, right? So these are the ones that come to mind. Documentation through types. Obviously, don't just do types. Documentation through naming and descriptions, and then stuff like the usage or a tutorial module or blog posts. So, first off, types as documentation. What's the problem with get user? Right. What is text and what's the other text? I could mix those two up. I don't know what's going on. How many implementations does arithmetic have? Like, a lot. Probably near infinity. So like types get us really far, and we love types as functional programmers. So, and types are essentially the domains that we're talking about. So like, what's this domain? It's machine integer to machine integer. Natural number to natural number. So only numbers above 0 to only numbers above 0. So we're starting to get an idea of like what these functions do. The only thing I can do with identity string is run the identity and then change the string. I can do absolutely everything here. Yeah. And then having DB user signifies that we're only talking to the DB. So what we want to do there with types is constrain the domains. So A to A has only one reasonable implementation. Void forces you to use fmap and nothing else because you can't do anything with the A. Diemap, you just look at the types to implement that function. So I think constraining our types helps us writing the code, but it also helps people reading the code. So before we add arithmetic int to int int, we can constrain that to num, or you can constrain it further to ring. And just like plus and multiplication with the identity element. So we should also repurpose the domains, but like make them more specific. So always when you type your text string and int types, well, nearly always. So which one of these is better?
Depends.
I'm gonna say you're wrong. And I got a good example why. So in the first, we have type username equals text, and we look up user with username, and we can pass in any arbitrary text into that. But now, if we new type username, we can make sure that, or we could like add a validation function that goes from text to username, and then use that in lookup user. That might sound familiar if you were at Joe's talk on pure script validation. And my last example, again, you know that this is just going to talk to the DB. Well, guaranteed that well, as long as the library author does that. But yeah, there's some trust in the end, I guess, when you have to talk to the outside world. So we had this get user problem, and now we can fix it by saying new type username around text. You can also new type password around text. And something beautiful about that is that you just don't add a show instance to password, and that way you'll never leak information. Then we have our DB type, and now our get user function is username to password and some database result. So I actually ran into some confusion. I've been working a bit with DAL, and I was looking at this expression from text function, and I was like, what the hell is the string there? I don't know what it does. I could guess from the text that it's like, this is like my DAL expression, and I'll get the expression back. But seriously, what's this string? So I had to like dive into the source code, so I followed this, and rummaging around, I eventually found pars and parsec, megaparsec, and it's this name of the source file that you're parsing. All right, what's wrong here? Doesn't really tell you what it's doing. I don't know what watch is, I don't know what unwatch is, and the only way I figure these things out is by going to the Redis documentation, and that's adding friction to your library. I have to like go somewhere else. Or even if they just provided the link to the Redis library, or documentation, I should say. So that's a bummer.
How will you improve that?
Yeah, so like I said, add a Haddock description, which we'll go through Haddock in a minute. Yeah, no, the types are good because it's like, these are Redis actions, and watch takes a non-empty of key, so it's like, all right, we need to watch at least one key. The types are good, but as you can see, names and descriptions is the title of this slide, and the names are decent, descriptions are very lacking. So we should be nice to our users, you know? We want people to use our libraries because they're our precious babies. They come along and like, then they get popular and it's like, cool, people are using my libraries. But like, I think the really good libraries have really good documentation. So we should use good naming. Shouldn't just use foo and bar everywhere. I think there's one library that has like, names all their type classes T and their data constructors C, and it's, yeah, it's not nice. And then we should also describe things, but let's look at a bit of naming first. Back to domains. Use the language of your domain when you're trying to name things, because people are going to come to your library, they're going to like expect a kind of language that they're used to. And like, it'll help you to write your code because you're thinking about the domain, and help others search it. So a few examples: banking, you've got your, well, customer, I should say, your account number. So like accounts are part of the domain, balances are part of the domain, withdrawing money, depositing money. We can talk about linear algebra. This could be wrong. But like vectors, matrices, tensors, multiplying matrices, dot product. So essentially just use the words of your domain to really talk about your library, or the problem it's solving. So naming things can be hard, but they can also be fun. So some of my favorite library names: Terraformo, the Terraform library; Esqueleto, actually almost says like SQL; Weeder, a tool for removing weeds from your repository. So when you're writing, or at least I know when I'm writing code, I come by like a complex piece of logic. I'm like writing out all the code, but sometimes I just like leave it there, and it's like, oh, type checks, ship it. But someone else might come along, or even yourself, and be like, what the hell did that do again? So don't write it and leave it as it is. Do write a description of the function itself, even if it's short. And then if you've got a complex block of code, try and leave comments throughout, describing like smaller parts of that large piece of code. Because we want to help users search the documentation, grok the documentation, and guide them. Because if you have someone new to your library and they want to contribute, it'd be helpful for them to look through and it's like, oh, that's what that does. So help new people by describing what you're talking about with the assumption that they know nothing or next to nothing, I would say. So use the simplest terms possible. Sometimes L-got zygo M just isn't the simplest term. So that's gonna like help others understand what you're talking about quicker and get them going as quick as possible. And never use the words obvious or obviously, because it's not always obvious to someone. Huh? I don't know, like, yeah, exactly. You're making it, if you use obvious, you're making it an assumption. And like, I don't know if irony translates in like plain text all the time. Yeah, I mean, I like to have fun in my blog post. So if your tone in your post is like, oh, I'm being funny here, then sure. But
How do you go with balancing that? So sometimes you can't really, in a comment especially in my code base, I'm not going to take the time to explain. There's a place where you use free monads. Like I'm going to call it a free monad and not take the time to explain.
yeah.
What is a monad? What is free? Right? So how do you kind of balance that with?
It's a good question because
Versus like there's jargon that may mean what you understand.
yeah, and that relates back to talking about your domain. It's like suddenly you're in the domain of free monads. And I guess the good thing about free monads is there's lots of literature about it. So, I mean, that's it. Like, if say you discovered the newest monad craze and you wrote it down in a library, I'd argue you shouldn't just like write it all out and then leave it there. Start talking about it. But if it's a established domain, then I'd say be less descriptive of like the actual thing. But then like describe the functions or morphisms that you're describing on the structure. Like they're gonna do something specific, right?
The obvious stuff, I mean, I appreciate what you're saying, but it's informational too. Sometimes you look at the code and you're trying to find a rocket science in it.
Yeah.
The obvious tells in your face. You're just having it, that this is really nothing special. Just look at this again. The obvious, but lots of scientific papers would have what obviously is wrong.
Yeah.
And it's actually helpful because it tells you this is trivial. Don't spend.
I would argue if it's so trivial, then why use the word obvious? If it's trivial, then you can explain it in the simplest terms. I mean, that was like the Richard Feynman method, right?
You can generalize that to just never use that verb. I personally find those statements that says obvious and trivial on papers really discouraging.
Yeah.
A lot of times just read that, it's like, I'm not getting this, ergo I'm gone.
That's why I'm saying I appreciate what you're saying, because it can be easily overlooked.
Yeah.
But at the same time, there is some information.
Or maybe if it's obvious, you can link to literature that describes it.
I think the better term there is trivial, because that has a formalized meaning. That
Yeah.
The trivial solution is it may not be trivial to you yet, you can have it work through it, but it's a specific meaning in the
But if the solution is identity,
Yeah,
it's trivial.
yeah. All right, but I would,
Like identity is a transformer, and you don't want it.
yes.
Trivial.
I would say, but don't exchange the word trivial for obvious.
Okay.
Yeah. All right. so it's time to go fishing. Has anyone written haddock before, or do you all just cargo cult it? Yeah, sorry.
What does that mean?
It means just like you use it without like looking into why it's that way. So it's like, oh, dash dash bar. Yeah, that seems to be like a haddock thing. I'll just use that. So I took some time recently and like went through some of the documentation, and it explains the things really well. So I'll reify it here. So for those that don't know, haddock is a ubiquitous tool in documenting Haskell code. It generates HTML, beautiful HTML of your code, and so it's a markup language inside your source code. So it lives beside your source code, and we'll see why that's super cool.
Does it use LHS?
I think you can, yeah.
Like, XML. Is it actually able to do something like
Yeah, I'm pretty sure. So there's a haddock command line tool, but I'm a stack user, so I just use the stack commands, which are stack haddock. And to generate the documentation for your package, or mylib, you call stack haddock mylib. And this will output something like this at the end of at the stack call, and you can open that in your browser. Check out your cool documentation, and then for the extra options, just stack haddock help. So these are our best friends in haddock, pipey and pointy, as I call them. So pipey goes above things and pointy goes under things. That's easy to remember because pointy points up. So we'll look at a couple of examples. Well, a couple as in like 4. So we can document our top level functions. So we can put it above the function, and then this will be generated alongside your function type in the HTML. You can also put it under the function signature. And we can do multi-line as well. This also works on type classes. So if you put it above your type class definition, that'll be describe your type class, and then you can describe each function inside there as well. We can also document our sum types. I prefer the pointy version of this. Also, yeah, this is the caveat of pointy. It goes beside things in data type definitions. So that's where my mnemonic breaks down. But he looks nicer, so that's the easy way to remember him. And
that? You can still put it below that. You just do it.
can you? Okay. Right, my bad. Yeah, cool. But he looks nicer beside. And we can do the same with our subjective, of course. And we can do the same on products. And then I swear this is the last example where you can do it on our function arguments. So this will generate, like beside your argument, it will say what it's doing or what it should be if you document it well. So there's a bunch of other stuff. So paragraphs, 1 or more new lines. There's the code blocks, so bird tracks or crazy eyes. In crazy eyes, you have to escape strings, otherwise it thinks it's a module. Yeah, and you can do code examples as well. So triple bird track, call the function and then the output. And another really cool thing is you can write properties in your documentation. And then if you pair this with doctest and doctest discover, you can have your documentation checked at compile time or like test time, which is super cool. And it also does hyperlinking for you. So if you do single quotes around an identifier that exists in scope, you'll get a hyperlink. So in this case, we can hyperlink to capitalize, and it'll take us to capitalize. Or we can hyperlink t.text, and that'll render as just text. And if you click it, you go to the data.text module. And same with first, and then you can hyperlink data.byfunctor, which is the module, and it'll take you to the module itself. So this is really handy for like surfing through documentations, like seeing where things lead. And that's essentially how I found the parse problem, like with passing in a string, it's just like click and click, click, click. Okay, there it is. And we can also add headers. So they're more common to do it this style. So when you're exporting from a module, this kind of groups your things together. So you got classes there, types, and then like a subheader of a data type, and then some functions. But you can also do it inline, which might force you to like keep things together in your file as well. And as I said, the documentation for Haddock is pretty good, so you can do like grid tables and other cool stuff. And I've got basically that Haddock tutorial in code where you can generate the Haddock and open up the index HTML and check out the code or the documentation. And I wrote a brief blog post on it, Medium. Also, this talk is on my GitHub. So if you want to check it out or need the links again. So I'm going to try something here. Remember that doll function? I'm going to make a live PR and document what the hell the string is. So wish me luck. All right. Oh, this is the worst rendering. Can you guys see that? No. Because neither can I. Tell me when to stop.
We should have like one letter on the screen at a time.
All right. Cool. That's all I can ask for. All right. So that's. Has everyone made a Git like pull request before? Cool. All right. That's like aiming for a low bar just in case. So I won't have to like talk too much. Document. What was the thing? Expression from text or text to expression, whatever. Cool. Actually, I might look at this guy to see where the hell that was. Oh no, wait. I can do it this way. Oh, it's in parser, of course. So, expression from text. There we go. All right. I don't know how Gabriel likes his indentation on functions, but he's just gonna have to live with it. So we introduce our pointy friend. I can try. I think that's as big as it goes now. All right, so string. What the hell is string? It was, input file. Actually, let's take a look where it was and pretty much just copy what it was called in megaparsec. Wait, where was that? Oh, there. Name of source file. That's cool. Name of source file. Save it. Don't add loads of white space. The text. Should I? All right. I'll name the text as well. Yeah. Yeah. Cool. All right. Commit documenting text. And Haskell. I suppose I'll pull this up. Text. Very confusing. Didn't know what string was. Documented inputs. PS hello from LambdaConf. See you at Zurich. Double check everything's cool. Nice. All right. And now the world's a bit of a better place because there's more documentation in it. Thank you. But I'm not done. Because, where was I? We need to reap the rewards, right? So, I don't know if you guys know Matt Parsons, but he's got a bounty on documentation. And he'll Venmo you $5 or donate $5 to a charity of your choice if you make a PR. I don't have Venmo, so I don't know what charity I'll pick. So we're just going to go over here and message Matt on Slack. It's like, hey, you owe me $5. We'll accept beers. Yeah.
Kind of along those lines, there's a relatively new project called Pipeline. It's one of these, blockchain things.
Yeah.
It's the same idea, but they're trying to do it for all projects. It's kind of interesting.
I've heard of something similar. I think it's called OS Coin, open source coin. Yeah, it seems like a cool idea. Yeah, as I promised, there was more categories. Documenting via usage. What's wrong here? This is something I wrote in my last job and left it there, but I don't think many people use Scaleway, and if they do, they probably don't use Haskell either. So unless someone creates an issue on this, I probably won't get around to it. But yeah, it was bad. So we should write, or try and write, at least a simple usage of your library. Most of the time I see this in the main module will have a module header describing some examples and running through what these functions do and how you can combine them. And speaking of Gabriel Gonzalez, I heard him say something spectacular during one of his Nix talks. He said, because we're talking through types, we can produce the data for the type, so like the creation. We can talk about the transformation of your type, and then how we consume it. So, like, for example, the most trivial example, identity. It's like, all right, we can create identity by using the identity constructor. We can transform values inside it by using fmap, and then we can consume that identity value by calling run identity. So actually, we'll look at some examples, and of course the first one is from Gabriel himself. Turtle. This is in turtle.prelude. This is the first thing you see. It's like how to use it. Set overloaded strings, because strings in Haskell. And then you're immediately on the track to let's cd to a file and like find out where we are. And he goes on to like describe the shell, which is like a type in Turtle for basically creating your shell commands. So the creation. Fold, well, so suffix and find are transformations, and then the fold is the consumption, and then we get a just value back. I think, and then for tutorials, I think that was the next, oh no, it was H-matrix as well. H-matrix has a pretty nice code examples page. So it doesn't have to be in your module, but there's a clear link saying code examples. And there's an introduction. And it's, how do we make a matrix? How do we make another one? How do we do linear solve on them? Question?
Yeah, like I have a comment around that approach.
Cool.
Like I've been trying to document my software like that.
Yeah.
And I'm noticing that after I create a version and change things,
Yeah.
it becomes rather difficult to do the same thing that Package does, where you have like different versions and you just go to the version you want to document. Right?
Okay, right.
So I was wondering if there's a way, if there's any strategy whatsoever to do those tutorials using just Haddock.
Well, if you embed them in your module, right,
So you will have to create, like, assuming you have modules dedicated to tutorials, and you have more than one tutorial, you will have to have like a bunch of tutorial modules there in every release.
Yeah. I don't know if I have a good solution for you,
Yeah.
but...
I just a couple packages that do that exact thing, and it seems to work.
Oh, cool.
I mean, it's like there's a module, it's clearly titled, this is the example or tutorial one. You're not actually trying to import anything from it, but you can click through it on package and get examples there.
Right. Yeah, right, yeah, that's like another approach Gabriel takes. Is like dal.tutorial is like a tutorial on how to use dal all the way through. And then I think the next step from usage is this tutorial. And the best tutorials I find give you examples or exercises to run through. And Snoiman does this really well on his conduit README. So basically he's got like some straightforward examples, and then he starts to he shows you like the weird stuff about conduit, which is never ending sometimes. But he eventually starts introducing the combinators, and if I can find where these examples or these exercises are. Here we go. Exercise. Work through what happens when we add pipe map C print. And like hopefully you like reason about it and try and think about it, and then you run it. And then there's other ones like, I'm pretty sure he's like, implement this function that exists in the library. implement iter.mc in terms of map.mc. I think that's the best way to like start to really understand how the hell this library works, because in a sense you are writing some of the library. And you can understand, just understand how it works. I think Matt wrote back. Hell yeah. So, one thing I hear about Haskell is it's lacking documentation. So what are we going to do about it? We should go out there and document and ask Matt for lots of money. So, does anyone have any questions? Yeah, so I meant to look into it, to be honest. I didn't get a chance, and I probably wouldn't have been able to fit it in this talk. I'm interested in it because I'm sure you can do interesting things like write littered Haskell and then use pandoc to transform it into your HTML. So something, actually, again, Doug Beardsley, he's getting lots of mentions today. I think he's got Snap Heist tutorial. Is it this one? No, that's the documentation itself. Oh no, the top link. This is all written in literate Haskell. So I definitely think it's useful. I just haven't experimented with it yet. I've also heard a good idea of like your test suite should be written in literate Haskell, because you're documenting like what these things do and giving proper examples that should pass as well. Anybody else?
Have you ever found that some library maintainers are hostile to having other people do documentation for them?
I haven't found any yet. I've like fixed typos and stuff, and they're usually just like, thanks. I don't know. And then Gabriel's super nice and responsive, so.
Some libraries almost look like they're designed to be obscure. I mean, if you look at some of the lens libraries,
Yeah.
who the hell would ever document some of that stuff? Except
Lens is a tutorial set. It's separate.
Yeah, they do, but the actual source code is very hard to read.
Yeah, I agree. And I'm trying to get into recursion schemes, and that's like a high bar as well, but I don't know. Have you tried to make a PR to Lens?
No.
Yeah. So I don't know if
I know a story about that though. I remember Gabriel Gonzalez trying to do a tutorial for Lens.
Yeah.
And he getting a lot of pushback from Edward.
Oh, really?
Yeah,
so heard this, yeah.
Oh, no.
That happened. I don't know. Like I think there was a resolution in the end because there's a Lens tutorial module somewhere.
Yeah.
But yeah, that happens sometimes.
Question also, like template Haskell is you can't really write documentation for it. Any words of wisdom how to deal with template Haskell?
Yeah, well, so
Keep it out.
if you're using a library, sometimes the documentation is bad, but you're still gonna persevere and try and use this library. And as you go along, you're picking up information. And I guess if they don't accept a PR, then just write a blog post teaching someone how to use it.
Haskell itself is an environmental community. So the question is, what do you do?
Oh, is in the generated code from template
yeah,
Haskell?
It's code for you, and it's like, no way.
Yeah.
Most important programming, and it's the same thing. We use a lot of template Haskell and a lot of script for this, both of those.
So like what the library I'm studying now, it's single points.
Yeah.
It's just, you look at this, and you have pages and pages of signatures, and they're all gibberish. Really? I mean,
Yeah.
it's like, so, his solution is to basically like extra documentation, right?
Yeah.
But
That's interesting. I've never used template Haskell myself, or if I have, it's just like the persist block of defining my database.
so okay, on the practical level, right? You should be able to make it. provide some sort of pointers to where this thing should be, right?
Yeah.
It sounds
Well-
like, well, I'm not sure if you're saying that you have an issue with it on the usage side of template Haskell or in writing your own template Haskell functions.
Documenting your own code that you use in the past.
So typically when I write like a template Haskell function, I use those, what is it, scary eyes?
Crazy eyes.
Crazy eyes.
Whatever you want to do. I made that one up.
So I'll like run the template Haskell block in GHCI and just print it, and then just paste that into the crazy eyes block. Like when you put in this is what you get out.
What
It's just a way of documenting template Haskell.
Can you output comments in template Haskell? Because that'd be interesting.
Sorry?
You can.
Can you output comments?
Yeah, you can actually have to generate comment code, but that's gonna be weird. You can do it. It's definitely possible.
Sounds like you guys are ready to like get in there and start writing documentation. Anybody else? Cool. I hope you enjoyed that.